Hi everyone. Today we'll be looking at the t-test. The t-test is one of the more common statistical techniques used in the social sciences. Now, t-tests are used conventionally when you're comparing two different groups. So for example, you might be comparing males against females, or you might be comparing an experimental group against a control group, or one class against another class. But the basic idea is you're comparing two groups and you want to get a sense of whether one group is performing at a higher level than the other group. So for example, suppose we have an experimental technique for learning math, and we want to determine whether this experimental technique is effective or not. So one way to do that would be to divide a large number of participants into two groups. You could divide them randomly, put a bunch in group A and a bunch in group B. And we'll administer the new math technique to group A, our experimental group, and in group B we'll administer the regular instructional technique, whatever that happens to be. After we do that, we can then test both sets of students using the same test, and we see which group performed better. Now, one of the problems with testing both sets of students is once you get your data back, suppose they look something like this. We have a bunch of scores for the group A students and a bunch of scores for the group B students. Now, how can we say for sure that group A is performing better than group B, or vice versa? Now, we could eyeball this and we can see, oh well, they've got a couple of 20s here and they don't have any 20s over here. But, you know, maybe that's just chance that one group happens to have slightly higher scores. We could also calculate the average. Let's get the group average score on the tests. Here we have an average of 16.14. And here we have an average of 14.875. So it looks like, just computing the averages, that group A is performing at a higher level. But we still don't really know. Let me show you another data sheet. Suppose we administered a spelling test to all the students in a class, and we got these scores. And now suppose we just divided these students randomly into two groups. Let's maybe divide them right about here. Just insert a blank row. So we've got one group at the top, one group at the bottom. And now we'll compare the averages. So it looks like this bottom set of students has a higher average than the top set of students. But you know, they all had the same instruction. It just so happened that the bottom set of students are slightly better at spelling than the top set. And whenever you divide a group into two groups, or randomly select certain students to be in one group and certain students to be in another group, obviously one group is going to slightly outperform the other group. And so this is our problem. How do we know whether this difference in means is just random because we have slightly better students in this group, or how do we know that it's a real effect and that this higher score is due to the experimental condition? Well, this is where t-tests come in. T-tests help us answer this question about whether mean scores are due to the experimental technique that we're studying or whether they're just random noise. So again, there's two hypotheses here. One is that there are no real differences between the groups and any differences in the data are just kind of random. Or the alternative hypothesis that there are real significant differences between the two means that are caused by our intervention, by our experimental condition, in this case the math technique. Now, the t-test is used to determine whether the differences between the means that we're observing is a significant difference. In other words, are the differences between the means great enough that we can consider it to be a real effect and not just the effect of some kind of random assignment of data. And here's how it works. The t-test first assumes that the null hypothesis is true. That is, that there are no differences between the two groups. And it then calculates what we call a p-value, which is the probability that the differences between the two means are just random noise. In other words, given the distribution of data that we've collected and the differences between the means, what are the odds that the differences that we see are just randomness? Now, if the p-value is less than 5.05, that is 5%, we reject the null hypothesis, i.e. this notion that it's just random, and choose the alternative hypothesis. So let's try an example. Okay, here what we're going to do is we're going to do a t-test between our experimental condition, so that's B4 to B17, comma, and now it's D4 to D19. Our next variable is tails. In other words, we want to check to see whether are we testing both whether group A is better than group B and group B is better than group A, or are we just testing one of those? And I think we're only really concerned with one tail, that is whether group A is better than group B. So I'm going to put a 1 in here. And then the type is the type of t-test, and there are a bunch of different types that we'll talk about later, but just for now I'm going to put in a 2 in here. And we get a value of 0.20 back. Now what this means is that there's a 20% chance that the differences that we have here are just due to randomness. And they have nothing at all to do with differences that are associated with the experimental intervention. Now in the social sciences, 20% is not a high enough score. So we can't make any claims that group A is performing at a higher level than group B because of the experimental treatment. Okay, let's try a different data set. Okay, now here the numbers are slightly different. Let's take a quick look at our averages. Okay, so again, group A has a higher mean score than group B. But the question is this difference statistically significant enough to warrant a claim that the experimental approach is beneficial? Let's run a t-test and find out. Okay, in this case, our t-test gives us back a value of 0.02. This means there's only a 2% chance that the differences in means is due to a random effect. And so, because this value is so unlikely, this difference is so unlikely, we assume that it is not random, and in fact, group A is performing better than group B. We write this by saying the data suggest that the experimental treatment leads to higher mean test scores, and then we say probability is less than 0.05. And this probability number signals to social sciences that we have conducted a t-test, and that in fact the values are significantly low that we can make this claim. Okay, so that's how to conduct a simple t-test. There are other types of t-tests as well, but we'll take a look at those later.